Now, the uncertainty principle is one of the key principles that explains the quantum mechanical world. It's a concept that was developed by the German physicist Werner Heisenberg, who was a pioneer in the field of quantum mechanics. Now, the uncertainty principle states that there's a limit to how much you can know about a particle's position and momentum, two fundamental properties of a particle, at the same time. So, in its most simple sense, it's saying that the more you know about where a particle is, the less you know about how fast it's going. In reality, it gets quite a bit more complicated than that. But it can be explained using the wave-particle duality that exists in quantum mechanics. Since a particle behaves both like a wave and a particle at the same time, we can look to the behavior of waves to explain the uncertainty principle's effect on particles. So, when measuring a wave's momentum or frequency, you need to look at the wave on a whole, just like the wave in the top left of the first image on the website. However, when looking at a wave on a whole, you can't actually identify its exact position. It's all along the wave, it's everywhere. So to determine the exact position, you need to narrow that wave down into a wave pulse, which you can see right underneath the wave. But the thing about a wave pulse is you can't really tell the frequency of its crests because it's isolated. It's just a pulse. There is no real frequency since it goes up and down. So essentially that's what it is. The uncertainty principle is that the more specific you get with where a particle is, the less you know about how fast it's going because you don't have a broad enough set to actually look at how fast it's going. Now, this uncertainty principle has a tremendous effect on quantum mechanics, and it's one of the biggest things that differentiates it from classical mechanics. Thing about classical mechanics is that there's always a definite value. There is no uncertainty. Everything's steadfast. But when you go down to the micro scale, that thing entirely falls apart, and you have to come up with a new set of rules for the environment at that size. And actually, in the second picture, you can see the different realms of rules that apply in physics, depending on speed and size. So one of the places where the uncertainty principle is most prevalent is in probabilities, since most of quantum mechanics is probabilistic. And a good example of that is the electron orbitals. The probabilities are used to create the orbits, and those are all governed by the uncertainty principle. And that changes the values and changes the shape. And overall, that is the uncertainty principle.